do is we will go to the second kind of factor analysis, which is confirmatory factor analysis, and see what is it that we are trying to do and how does it work, how do we estimate, how do we capture, how do we measure, do confirmatory factor analysis. For that, we will be using SEM software. We will be working with AMOS, okay, and we will do some exercises using AMOS and see estimate factor analysis. Okay, so I see a question from Surabhi. So every time, even if it is one item or two item, actually it is akin to developing the moment you are saying you are measuring, creating a measure for a construct, you are essentially going through all these, you have to think about all these questions of reliability and validity. If you have one item, then obviously you cannot test reliability. I mentioned this yesterday. For testing reliability, you need at least two items. Okay. If you have two items, you can compute reliability. And remember, what can happen is in some papers, because this is just a very small part of the paper, just two items, so people uh, may not actually go through or mention or specify all those steps of validity. But remember, the issue of validity will always remain. Some reviewer can ask you, how did you write these two items for your construct? And if that construct is your outcome variable, then you will have a problem, because you will now have to convince that these items are valid measures of your construct. So my advice is one item or two items, whatever it is, at least be mindful that there are these questions that you will have to answer, and then go forward. And if reviewers ask you these questions, you can try and answer to the best of your knowledge. Have being mindful of those questions right in the beginning when you are writing those items. No, we cannot. Actually, AMOS that we are going to work on is also a software by IBM. Okay, but it is a different software. So we usually we have to do confirmatory factor analysis in AMOS. SPSS is does not allow us to do confirmatory factor analysis, right? So we'll do it. Okay, so let me before we actually do some session on. Okay, so the difference between AMOS and PLS is there are two kinds of SEM that we have today. One is called as covariance based structural equation modeling, okay, and PLS is partial least square structural equation modeling. Now, actually, if you look at purest version, people say that covariance based structural equation modeling is better, okay, and therefore AMOS and working with CB, we call it as CBSEM, which is covariance based structural equation modeling. So you have two, you have covariance based SEM. This is called as CBSEM. You may read this in some papers. This is called as covariance based SEM, okay, structural equation modeling, and PLS SEM, which is partial least square SEM. Okay, so this actually statisticians say that this is not the SEM. It is limited in a lot of sense. It does not give you model fits. Okay, it does not allow you to do. So this is said to be more accurate. This is said to be the actual form of structural equation modeling that should be followed. There are criticisms of why PLS SEM is actually not the right kind. It is actually not uh, structural equation modeling. Okay, so anyways, what I will be teaching you is CBSEM, covariance based structural equation modeling. There are, if you understand fundamentals of CBSEM, your uh, understanding PLS SEM will be quite easy. So what we will be doing here is going to be covariance based SEM. This actually is more comprehensive in analysis. Okay, it gives you a uh, uh, lot more functionalities, lot more details in the output. As I mentioned, model fits are reported in CVSEM. So this is something that we will do for the time being. I will not be going into PLS SEM. However, if you understand CBSEM, you will be able to do PLS SEM also. Follow PLS SEM. There are tutorials available online which you can based on your understanding of CPSM, you will be able to. So actually, Dr. Richa, I actually teach PhD students at my institute everything using R. I am not teaching you all here because there is some amount of learning that is needed uh, in R. Okay, but at our institute, I teach everything about in psychometrics, reliability, validity, SEM using R. So you can do uh, everything that I am telling you here, reliability testing, convergent, discriminant, nomological, SEM, everything can be done using R. Okay, so that I will leave it for maybe some other workshop of mine. But at this time, I just want to give basics of. So yes, but answer to your question, everything can be done in R. And the beauty of that software is it is open source, free of cost. You don't have to buy licenses for like SPSS or AMOS. Okay, so that is yeah. PLS, well, actually there are lots of misconceptions about PLS that is good for non-normality and all of that. Actually, you can do everything in CBSEM also. Formative constructs can also be estimated. Non-normal data can also be tackled using CBSEM. So that does not uh, no, Praveen, you should not delete even if your reliability remains the same. Remember, each item is capturing some data. So you should remember if you drop an item, you are missing out on some information that is captured through your item. Don't try to jack up your alpha. Remember, anything above zero point 0.7 is very good. So you are already getting zero point 0.9. Why do you want to drop items? You already have uh, 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 you already have zero point 0.9, so there's no need of dropping. Brinda, I just mentioned everything that you have that I am teaching you here can be done in done. Okay, so everything can be done. Okay, so let us let me take you through some basics of SEM and what do we mean when we are talking about structural equation modeling. Okay, so if you remember, yesterday I had drawn a diagram, something like this. Okay, and I was uh, explaining different kinds of validities. Now, what do we understand when we use this term SEM? Okay, it stands for structural equation modeling. Okay, not S actually, it is structural equation model. Now, uh, what does structural equation modeling? Structural equation here, it means nothing but regression analysis. Okay, regressions. So at the end of the day, what are we going to do? We are going to test regressions. Now, what is the advantage of uh, structural equation modeling over normal kinds of regression? Remember, we had mentioned in our measurement equation, we had written this fundamental equation: x observed is equal to x true plus measurement error of x. That means there is whatever is observed, it has some true component, which is the actual latent construct that we are intending to measure, and there is some measurement error. Now, if you were to do regression analysis in SPSS, we are essentially going to work with everything. What would you do? You had 10 items, and if you were to do regression analysis in SPSS, you will take the mean of these 10 items and you will get one leadership number. Okay. You will take mean of the 5 items of PJ and you will get one item of PJ, and you will take the mean of 6 items of creativity and you will get one item for creativity. And then what you will do, you will start regressing. So you will first regress PJ on leadership, you will get some beta here. Then you will regress creativity on PJ, you will get some beta. Let's call this as beta 1, beta 2, and you will regress creativity on both PJ and leadership. So you will get beta 2 and beta 3, and you will report this kind of a result in your uh, papers. But the advantage of SEM, remember we are saying that X observed, you have created this based on the leadership observed variables. You have, but all of this observed is not because of leadership, it has some measurement error. So we should actually be interested in, we are most interested in working with X true. We don't want to work with X observed because it has uh, confounding, it has influence of measurement error. We should actually be regressing instead of leadership observed. What do we want to do? We want to regress leadership true. We want to have PJ true, and we want to have creativity true. And I want my regressions to be between the true constructs because they are the actual latent constructs that I am interested in. Now, this is something that is not done when you are doing regressions using SPSS or any other, when you are doing simple regressions. That is one limitation. The second limitation is you have multiple variables, so you will have to do one regression at a time. You will regress PJ on lead, then you will regress creativity on maybe PJ, and then you will regress creativity on only lead, and then you will regress creativity on both PJ and lead. So you will have to do 4 runs. You will have to do 4 runs to test these 4 relationships. Now, how is structural equation modeling so useful, and why has it become so popular in behavioral domain, in social sciences, wherever we are talking about latent factors? So you see, the first thing that we can do, we can we have what we call as the measurement model for leadership. So in structural equation modeling using CFA, okay, using CFA, we will actually be testing the measurement model. We also call this as measurement model. We will be testing the measurement model. We will call this as CFA for leadership. Okay, and what have I extracted? Based on these 10 observed variables, I have extracted this latent factor, this circle here, actually now becomes my leadership true. This has become my true construct. Similarly, I will have 5 items for PJ, 1, 2, 3, 4, and 5. Now, what have I done? I have estimated the measurement. So this will be called as CFA for PJ, and this will be called as CFA for creativity. And what have I done? I have, based on this measurement model, I have got to the true values of leadership, PJ, and creativity. And then what I will do in structural equation modeling is I will estimate the regressions or path model between my latent constructs. This is what these regressions is what I was interested in. And now when I have estimated true values of leadership, true values of PJ, and true values of creativity, I will now estimate relationships between these three and report what are the coefficients between these three constructs. Okay, and now the advantage, so the first advantage of SEM is you can do CFA as well as regression testing at the same time, which was not possible in normal regressions. You will either do only factor analysis or do regression, but here I will estimate this whole model at the same time. I will estimate measurement model of leadership, measurement model of PJ, measurement model of creativity at the same time, and then also test relationships between these. And the second advantage is, you see, here I was limited to one regression at a time. If you go to SPSS, you can only have one outcome variable and you can have multiple X variables. But when you are doing regression, you can only regress one outcome variable at a time. But here I have multiple outcome variables. I am testing this whole relationship at the same time, right? So this is one. This is actually what is structural equation modeling is called as a mix of psychometrics plus econometrics. What is psychometrics? Psychometrics is your measurement, where you are estimating measurement models, CFAs, right? You are doing CFA. These are 3 CFAs that we have done. So it's a mix of psychometrics and econometrics. What is econometrics? Econometrics is regression analysis or regression testing, or just doing regressions between constructs. Now, what have I done? I have now testing regressions between the true constructs and not the observed values. So that is the advantage. And this green line model, the model that is within this green dotted line, this is called as our structural model. Some people also call it as path model, structural model, and measurement model. So you can do everything at the same time, and therefore this technique gets the name structural equation modeling. Remember, structural is nothing but you are doing regression testing, but you are doing regression testing between the true constructs, the circles, right? So this is what we are going to do, and this is what is the meaning of structural equation modeling.